The new kind of aurora is not an aurora at all. This is according to American Geophysical Union. Alberta aurora chasers capture Steve, S-T-E-V-E for short. It's a new to science upper atmospheric phenomenon. On the evening of April 10th, 2018, in Prince George, British Columbia, Canada, fellow aurora chaser Robert Downey kneels on the foreground while photographer Ryan Salt captures the narrow ribbon of white-purple hues overhead. As you can see, it's not anywhere like the Aurora Borealis and Northern Lights. It's a very thin, narrow, whitish light, looks like a belt, almost vertical. The vibrant green aurora is seen in the distant north, located to the right in the photo. In this issue, Gallardo-Lacourt et al. Used a ground-based all-sky imager and in situ satellite data to study the origin of Steve, S-T-E-V-E for short, and their results demonstrate that Steve is different than aurora since the observation is characterized by the absence of particle precipitation. The ribbons of purple and white light that sometimes appear in the night sky were dubbed a new type of aurora when brought to scientists' attention back in 2016. But new research suggests that these mysterious streams of light are not an aurora at all, but an entirely new celestial phenomenon. Amateur photographers captured the new phenomenon called Steve on film for decades, but the scientific community only got wind of Steve in 2016. When scientists first took images of Steve, they realized the lights were slightly different than light from typical northern lights, the Aurora Borealis, but were not sure what underlying mechanism caused them. So in a new study, the researchers analyzed Steve in an event that took place in March 2008 to see whether it was produced in a similar manner as the northern lights, the Aurora Borealis, which happens when showers of charged rain down into Earth's upper atmosphere. The study's result suggests that Steve is produced by a different atmospheric process than the aurora, making it entirely new type of optical phenomena. Quote, "Our main conclusion is that Steve is not an aurora," end quote, said B. Gallardo-Lacourt, who is a space physicist at the University of Calgary in Canada. Calgary is in Alberta. And B is the lead author of the new study in Geophysical Research Letters, a journal of the American Geophysical Union. And B goes on to say, so right now we know very little about it, and that's the cool thing because this has been known by photographers for decades, but for the scientists, it's completely unknown, end quote. The study authors dubbed Steve as a kind of sky glow, or glowing light in the night sky that's distinct from the Aurora Borealis, the northern lights. Steve is totally something different, and Steve can help scientists better understand the upper atmosphere and the processes generating light in the sky. This is according to the authors. Quote, "This is really interesting because we have not figured it out, and when you get a new problem, it's always exciting," said Joe Borowski. He's a space physicist at Space Science Institute Los Alamos in New Mexico, who is not connected to the new study. He says, "It's like you think you know everything, but it turns out you don't." This is a different kind of light show. Auroras are produced when electrons and protons from the Earth's magnetosphere, the region around Earth dominated by its magnetic field, rain down into the ionosphere, a region of charged particles in the upper atmosphere. When these electrons and protons become excited, they emit light of various colors, most often green, red, and blue. A group of amateur auroral photographers brought Steve to scientists' attention in 2016. A Facebook ground called the Alberta Aurora Chasers occasionally noticed bright, thin streams of white and purple light running east to west in the Canadian sky, when they photographed this aurora. Auroras are visible every night if viewed conditions are right, but the thin light ribbons of Steve were only visible a few times a year. The light from Steve was also showing up closer to the equator than the aurora, which can only be seen at high altitudes. The photographers first thought the light ribbons were created by excited protons, but protons can only be photographed with special equipment. The light protons produced falls out of the range of the wavelengths picked up by normal cameras. The aurora chasers dubbed the light ribbon occurrences Steve, a reference to the 2006 film Over the Hedge, when researchers presented data about the unusual lights at a 2016 scientific conference. A fellow space physicist proposed converting the name into the backronym STEVE, which stands for Strong Thermal Emission Velocity Enhancement, STEVE for short, and that's what the researchers adopted for it. So where does STEVE come from? Scientists started using this data from satellites and images from ground-based observatories, trying to understand what causes this unusual light. The first scientific study published on STEVE found a stream of fast-moving ions and superhot electrons passing through the ionosphere right where Steve was observed. The researchers suspected these particles were connected to Steve somehow, but they were not sure whether they were responsible for producing it. So after that first study, of which Gallardo-Lacourt was the co-author, the researchers wanted to find out if Steve's light is produced by particles raining down to the ionosphere, as typically happens with the northern lights, the Aurora Borealis, or some other process. In the new study, Gallardo-Lacourt and her colleagues analyzed Steve event that happened over eastern Canada March 28, 2008, using images from ground-based cameras that recorded auroras over North America. And they coupled the images with data from NOAA's Polar Orbiting Environmental Satellite 17, POES-17 for short, which happens to pass directly over the ground-based camera during the Steve event. The satellite is equipped with an instrument that can measure charged particles precipitating into the ionosphere, and the study results suggest Steve is an entirely new phenomenon distinct from typical northern lights. The POES-17 satellite detected no charged particles raining down to the ionosphere during a Steve event, which means it is likely produced by an entirely different mechanism, according to the authors. The researchers said Steve is a new kind of optical phenomenon called Skyglow. The Skyglow. The next step is to see whether the streams of fast ions and hot electrons in the ionosphere are creating Steve's light, or if this light is produced higher up in the atmosphere. So, the conclusion is that they still don't know what Steve is and what's causing it, this sky glow. I'll leave a link below for you for this. It's from Geophysical Research Letters on Steve, and it's on phys.org, provided by the American Geophysical Union. Kindly support by contributing to my Patreon account. You'll find it in the description box below. Thank you.